Okay, next we're going to start the IO zone-based policy firewall. We're going to have first take an overview of what this is. Then we're going to go to a simple configuration of 2 zones. Then we're going to combine that with NAT. We're going to go to 3 zones. We're going to go then to deep packet inspection, application inspection, and then to the self-zone firewall policy. So just an overview of what this is. Now this is, so the ZBPF, it's also known as zone-based policy firewall. Now depending on which document you read, it's also known as zone-based firewall, ZPF, or just zone firewall, or so ZF, or zone policy firewall, ZPF. It's a lot of naming conventions in there. All of them mean the same thing. It's going to be a stateful firewall implementation on the iOS, which replaces the old CBAC, context-based access control, which was the initial version of stateful firewall on the iOS routers. So it's a stateful firewall implementation on the iOS routers. It supports deep packet inspection or application inspection. It inherits a lot of the engine inherits a lot of things from the CBAC world, but it has a zone-based policy firewall has a way different functionality and it's way different. It's very different built behind the scenes as opposed to CBAC. So it is based on the concept of logical security zones, and firewall policies are built between security zones. I highly encourage you, as you try to understand Cisco's IO zone-based policy firewall and the ASA firewall of Cisco, to try to make a comparison between those two, because they are very similar into what they do, how they work. Just configuration wise, it is a bit different. Now I'm going to put a question now to you out there till I'm going to continue with the zone-based policy firewall. Like, what is the, except the newer codes, when Cisco added also zoning to the ASA firewall in 9.1 something, then before they added zones, what was the zoning concept on the ASA firewall? Because there was a zone concept as well. So either way, on the iOS firewall, we're gonna build firewall policies built between zones, and those zones are nothing else but some logical segmentation of the network. Configuration wise, is going to be modular and hierarchical. So you're going to be, as you're going to see, it's going to make much more sense till once we're going to finish all of the options, not all of them, what is needed for the CCNP exam. Once we're going to go through a lot of, let's say, options and configurations, it's going to make much more sense why this is modular and hierarchical. So it's modular because we can match very, let's say, the matching of the traffic, it's very, let's say, specific, very modular. And it's hierarchical because we're going to be able to build a hierarchy of firewall inspections using zone-based policy firewall. And configuration wise, it is based on Cisco Common Classification Policy Language, or C3PL. C3 meaning 3 C's, Cisco Common Classification Policy Language. Now the building blocks, again, which is very important to understand in any technology. Once you understood what it does and how it works mainstream, you gotta know the building blocks. So as you're gonna see, the building blocks are gonna see that we have to define security zones to begin with. Then we have to classify traffic to be inspected by the firewall. Then for the classified traffic, what do we want? How do we want the firewall to inspect that traffic, or what do we want the firewall to do with that kind of traffic? Not to inspect. So once we match classified traffic flowing to the router to the firewall, now what do we want the router or the firewall to do with each class of traffic? Then we have to activate or enforce those firewall policies between security zones. And the last step is going to be attach interfaces to the security zones. Now, if you read a lot of documents out there, they state that the attachments of security zones, I mean order of operation, in a lot of documents, it's not this exact order of operation, but this should be the order of operation that you should use in a production environment. It's going to make a lot of sense when I'm going to go to the configuration part, and once we've gone to the whole overview of this zone-based policy firewall. But the problem is that if you don't have the last step to attach interfaces to security zones, like if you bind interfaces to a zone before configuring the firewall policies, then all traffic is going to be dropped. So that is a problem. So you wouldn't want to first put an interface to a zone, attach an interface to a zone before you define firewall policies, because most of the traffic between zones in there is going to be dropped till you configure them, so it doesn't make sense. That's why this should be the correct order of operation. Doesn't make sense to bind an interface to a zone before configuring the actual firewall policies between zones. Now let's take it one by one. So security zones. We have two types of zones: system predefined and user defined, which means you're going to define some zones in there, and some of them are predefined by the router. System predefined, it's only one. It is named the self zone, and that zone cannot be changed, like the name, or deleted. And as the name states, the self zone, it means it's the router itself. It is going to be responsible with traffic destined to the router or initiated by the router, which means management plane and control plane traffic. And we have user defined zones, where you pick up a relevant name. So you want to define those zones which you configure on yourself. You're going to put in there relevant names, and those zones are going to be responsible for traffic transiting the router. So data plane traffic that the router routes back and forward between its interfaces. Now, a zone, pretty much all firewall vendors have this concept. It's, as I said, a logical segmentation of your network. Like, for example, and that's going to be our use case as well in the end. If we look in here on, let's suppose that, so this is a remote branch of an enterprise, and this is the headquarters of that enterprise. So what this means is that I'm going to want to go on router 1 and enable zone-based policy firewall. So router 1 has 3 routed interfaces: the one facing the internet, the one facing the LAN, and the one facing the let's say the headquarters. Which what this means is that clearly this interface, so I'm gonna go and look on the router and define some logical zones depending like on the trust level of networks reachable out to each destination. Like if this would be, as I stated, one company with 2 sites, then what this means is that this interface facing the internet, I'm going to define it to be like the internet zone. But then these 2 interfaces, the tunnel interface and the LAN interface, both of them are actually, let's say, trusted interfaces, because both of them point to networks which belong to our enterprise. So both of those 2 links are going to be a member of the same, let's say, LAN zone, or whatever you want to name it. So what you do is you look at that device and you logically segment the network into types of zones, like trusted, untrusted, DMZ, whatever. And you can put multiple interfaces to a zone or a single interface. So that segmentation of the in zones is being done logically to like the trust level of interfaces on that device. So if I do this, it means that all traffic routable in that destination belongs to the internet zone, and all traffic routable in this direction or in this direction belongs to the LAN zone. Well, if for example this would be, as I stated before, if this would be the company 1, this would be company 1, and this would be company 2. So if that's the case, then in this case I cannot consider both this gig00 interface and the tunnel interface to be of the same trust level, because gig00 points to the LAN, the tunnel points to an external partner. So if this is my use case, then the gig01 interface is going to be a member of the internet zone. The gig00 interface is going to be a member of the, let's say, LAN zone. And the tunnel 12 is going to be a member of, let's say, the WAN zone, or whatever I give it, partner, whatever. So this means that all prefixes, all destinations routable out gig00 are going to be a member of the LAN zone. All prefixes reachable routable out on the tunnel, member of the WAN zone. All prefixes or routes, destinations reachable out on gig01, member of the internet zone. So you do this logical segmentation based on your own criteria, and it's just going to be done based on the trust level of destinations reachable out on a routed interface of the router. Now, next step, traffic classification. So we have to now classify the traffic in order to take firewall actions on each type of traffic. So we want control on which traffic flows to the firewall and what does the firewall do with that type of traffic. So classification is being done to a regular class, to a class map, but of type inspect. And we have two types of class maps: layer 4, it's also known as layer 3, layer 4 class map. Some documents state it's going to be a layer 3 class map, a layer 4 class map. Layer 3, layer 4 class map is the same thing. This is used for traffic classification, like match on telnet traffic, match on TCP traffic, match on UDP traffic. The layer 7 class maps are used for application inspection, as the name states, or for deep packet inspections. We will get the layer 7 class map later on. Now the layer 4 class map classify traffic. So when you build that class map, how do you match on traffic? You're going to match on traffic or classified based on an access list or based on a protocol. Or as you're going to see also, you can call in a layer 4 class map another class map, which means class map nesting. And there we go, one example of hierarchy. Now a layer 4 class map may contain multiple classification criteria, multiple match statements. Thus, when you define a class map, it can be defined as a match any, which means it's an OR operation between the entries in a class map, or a match all, which is the default if it's the default class map type, which means it's going to be an AND operation between the entries in the class map, between the conditions in the class map. So with the AND operation, it means that all criteria in the class map have to be met. All match statements have to be met successfully in order for traffic to match on that class map. Now once we match, we classify the traffic, we want for each class map to tell the router what to do with that traffic, with each kind of traffic. And when we define the firewall policy rules, this requires the use of inspect type policy maps. And likewise, we have two of those. Layer 4 used for firewall policies, like stateful or not stateful firewall inspections, or layer 7 used for application inspection or for deep packet inspection. Likewise, for the moment, we're going to focus on the layer 4 policy maps. Now each layer 4 policy map can reference, as you're going to see, multiple layer 4 class maps, which means the router is going to evaluate those class maps in the order of configuration, top down, just like in a route map. So on one policy map, we call in multiple class maps. And for each class map, a firewall action needs to be defined because each class map identifies some type of traffic. Like we're going to have class map A to match on HTTP traffic, class map B on FTP traffic. And we want to take different actions for each of those two types of traffic. Now, if traffic flowing to the router doesn't match any of the user configured class maps, what you have configured like class map A and B, then unclassified traffic will match on the default class map named class default with a default action of drop. And that is expected. So, because when you define the firewall policy, you want to say, I want to do something with the HTTP traffic, something with the FTP traffic, and that's it. And everything else is going to be dropped because it's going to match on a class default. Now, what are the layer 4 policy map actions? We have the inspect actions, which pretty much this is what you're going to use in general. Which means the router is going to allow traffic, but in stateful mode. So it's going to create, track, delete the session state in there. So it's going to keep an entry in the state table. Once it's going to allow traffic, so traffic flowing to the router matching an inspect action is going to create an entry in the firewall state table. So the router keeps track of the session state to allow traffic back and forth. The pass action, it means allow traffic in stateless mode. So it behaves like an ACL permit action. And in general, you're going to use this kind of firewall action for protocols not supported by the inspection engine. So for protocols that the router cannot inspect to create the session state and track it, like GRV and ESP. So in general, the pass action, we're going to see that is being used either in with the self zone, that's not a use case, or for data plane traffic, it should be used in general only for traffic which doesn't support the inspect action. We're going to see why that is. So the router cannot statefully inspect at this point GRV or ESP traffic. Or of course we have the drop action, which it's self-explanatory what it means. If traffic if you match a traffic in a class map, and then for that class map you set the drop action, traffic is going to be dropped. We have other additional actions in the layer 4 policy map. So as an addition, we can say log, which means I want the router to generate a log message, and that can only be added as an additional action to pass or to drop action, not to inspect action. It's going to make sense in a bit why, because again everything makes sense. All of those restrictions actually they make sense. So you cannot put the log option as an addition to the inspect action, because the inspect action has its own way of logging if you want the firewall to do that. And we also can say police, an additional action. So you cannot say log by itself or police by itself. Those two actions, log or police, can only be additional actions to inspect, pass, or drop. So of course log can only be added, as I stated, as an additional action to pass or drop, not to inspect. Inspect has its own way to log a message or not to log a message. And police doesn't make sense to police with drop action, right? So police cannot be used with drop. Police is going to be used with pass or inspect. So for traffic policing or rate limiting. So as long as traffic is allowed by the router via inspect or pass, you should be able to police it. Now once we have, so we match on our traffic in different class maps, then we build for each class map, we told the router what to do, to pass it, to inspect it, to drop it. Then we have to enforce the firewall policy. So to keep it simple is like if you want to compare what we've done so far with like a regular ACL, it's like so far we build the access list pretty much, but in a different way. We match on traffic, we told the router what to do with each kind of traffic, But now we have to enforce the rules, which means we have to apply the access list if we want to compare this with a regular ACL configuration. Now, to enforce the policy rules, the firewall rules, this requires the use of zone pairs. There's going to be logical bundling of two zones, which also defines the direction of the firewall policy. Like, as for example, a simple configuration would be, I'm going to walk you through those blocks in the end after we do the config. But for example, you build a class map. In the class map you match on HTTP. Let's say HTTP traffic. Then you build a policy map. So policy map. And in the policy map you call that class map and you're saying, for that HTTP traffic, what do? Let's say inspect. So you want to inspect HTTP traffic. But then for which traffic flows? So if you have that configuration which states this is the LAN zone, this is the internet zone, and this is the WAN zone, then let's say I want to inspect HTTP traffic flowing this way, from the LAN to the internet. So that's what you do with a zone pair. You create a zone pair. I want to walk you through these boxes again to the config. It's very important to understand the connection between those boxes. You create the zone pair where you're saying the direction of the traffic flow from the LAN. If traffic goes from the LAN out on the internet, I'm going to apply this policy map, this firewall policy. So now, as the router sends traffic from the LAN to the internet, it's going to take action to what this configuration states, which means HTTP traffic is going to be inspected, all of the traffic dropped, as you're going to see in a couple. So the firewall policy, which is defined in the policy map, like the actions, pass, drop, inspect, is activated by referencing the layer 4 policy map under the zone pair. So it's going to be applied to traffic originated from the source zone in the zone pair and forwarded out to the destination zone in the zone pair. And a single policy map can be referenced by each zone pair. It makes sense. The zone pair defines the traffic direction, the firewall policy direction, and then you apply, okay, in that direction, how do I control the traffic? By attaching a single policy map. And in that policy map, you have multiple class maps, and each class map with its different action in there. And the last step is to, as I stated, to actually assign interfaces to those zones. So physical like the gig 00 or logical like the SVTI tunnel 12 interfaces will be assigned to user-defined zones. And of course, one interface cannot be a member of multiple zones. Doesn't make sense, because it's like you're saying like one interface, it belongs to both the internet and to the LAN. That's not possible. And interfaces cannot be assigned to the self zone, only to user-defined zones. That also makes sense. Once we're going to go to the self zone configuration. Now, traffic control. Traffic between user-defined zones and the self zone is allowed by default, but it can be restricted by the defining firewall policies. So what this means that it makes sense. Once you have defined, so this is your LAN zone. This is your internet zone. This is your WAN zone. In a define a firewall policy, even without defining, in our case, let's say we define a firewall policy from LAN to the internet initially, in that direction. So LAN to internet. So traffic going from LAN to internet is going to be, let's say, controlled by the configured policy. But then all traffic destined to the router, doesn't matter from which zone, if it comes from the WAN zone to the router, from the internet zone to the router, which is the self zone, from the LAN zone to the router, or the other way around, initiated by the router and destined to the LAN zone, or initiated by the router destined to the WAN zone, or the internet zone, that traffic is allowed by default. And that's a safety mechanism to make sure you don't lock yourself out of the router. So it's a safety mechanism to make sure that control plane and management plane traffic still works once you configure zone-based policy firewall. But as you're going to see, we may want to also restrict traffic to the self zone or from the self zone for specific reasons. So by default, traffic to the router or from the router, it's allowed. And that makes sense. Now, intra-zone traffic, like traffic within one user-defined zone, likewise, it's allowed by default, but it can be restricted by defining firewall policies. And this makes sense. Like, for example, if I consider this interface and this interface, both of them to belong to the inside or to the LAN zone, inside zone, which is the use case where that tunnel is between a branch of the company and the headquarters. So if both of those interfaces belong to the same zone, which means it's the same trust level, it makes sense that by default traffic is going to be allowed to flow both ways without me having to configure anything, because it's the same trust level. But of course, you can go ahead and restrict that traffic by defining firewall policies. Now, traffic, interzone traffic between zone A and zone B, it is dropped by default, and it makes sense, because that's why you segment the router into multiple zones, because you want to take control over what traffic flows and how does it flow between zone A, which is the LAN, and zone B, which is the internet, for example. So interzone traffic is dropped by default. You have to configure firewall policies and control what traffic is allowed and how is it allowed. Pass, drop, inspect. Now, traffic between a zone assigned interface and a no zone assigned interface is dropped, cannot be fixed, it's invalid design. So like if you accidentally, if initially, what this means that if initially you didn't have this tunnel, for example, initially router 1 had this interface, member of the LAN zone, and this interface, member of the internet zone. And you had firewall policies defined in there to control traffic flowing, let's say both ways, from LAN to the internet and the other way around. And later on, you come on and bring that SVTI tunnel between those two routers. You bring this SVTI tunnel. At this point, because this SVTI tunnel is not assigned to any interface, if it's not assigned to any interface, all traffic flowing this way both directions or this way both directions, it is going to be dropped. So this is an invalid design. And it makes sense, because you define firewall policies to control all traffic flowing back and forth to the router. So leaving one interface not being assigned to any zone doesn't make sense. It's like, you know how this is? It's like you have a firewall, a stateful dedicated firewall, like a DSA firewall or what a vendor's firewalls, which they have built in the design of zones, of logical security zones. It just works a bit differently. It's like then you would go on the DSA firewall and tell him no security levels. You cannot do that, right? You cannot disable that. For the same reason, on the ASA firewall, if you leave interfaces which are not assigned to any zones, it's an invalid design. Okay, let's see if we have any questions. Okay, not really. So nobody answered to my question. By default, the ASA firewall has a kind of zoning concept, which is nothing else but the security levels, right? So based on security levels, the DSA allows some traffic to flow by default, high to low, drop some traffic by default, low to high. And also in the case of ASA, like intra-zone traffic, like traffic between the same security levels is by default dropped, correct? So before they added the real zoning concept on the DSAs, DSA had a pseudo version of the zoning concept through the use of security levels.